Optima's niece Jenny works in the shop taking orders and drawing quilt diagrams. When the shop isn't too busy, Jenny pulls out her math homework and works on it. One day she is working on graphing parabolas. Remember, parabolas are what we have been working with. They are the x squareds that make the U shape. We just haven't called them that. Okay, y equals x squareds. She notices that the equation she is working with looks a lot like an order for a quilt block. For instance, Jenny is supposed to graph the equation y equals x minus 3 squared plus 4. She thinks, that's funny, wouldn't this be an order where the length of the square is reduced by 3? So we'd have one of those regular x squareds. We'd go backwards 3 this way, backwards 3 this way, so this is our new x squared. And then we would add little pieces of fabric that has an area of 4. We don't usually get orders like that, but it still makes sense. I better get back to thinking about parabolas. So that is what it would be in the real world, is you would take the big square and actually make it smaller, and then add 4 little pieces of fabric. But I usually do it like this, where I take the big square for you right here, and then we just add negative x's. Instead of making it smaller, we'd say negative x, negative x, negative x. It just makes more sense mathematically. And then, so this would be the square x minus 3 squared, so we would have the minus 3 squared right here, because this is x minus 3 and x minus 3. And then we'd have to add 4 little blocks. So that's how I've been doing it for you. It is slightly different if you were thinking the real world, but this makes more sense for the picture. Anyway, let's look at the parabola in her homework. The parabola in her homework was this one, okay? Thinking about what we've done with graphs before, we know that this negative 3 shifts it to the right 3 and up 4. Go back and look at 2.1 and 2.2. Well, if the original graph is this, that means it went to the right 3 and up 4. So here is the new graph. It would have a vertex of over 3 and up 4. And that means it would have an axis of symmetry right down the middle at x equals 3. So that's just a review of graphing transformations based off of what this is called vertex form. Okay. Jenny returns to her homework, which is about graphing quadratic functions. Much to her dismay, she finds that she has been given x squared minus 6x plus 9. Oh dear, thinks Jenny. I can't tell where the vertex is or identify any of the transformations of the parabola in this form. Now what am I supposed to do? Right? Because this is that standard form. It's the form you get that if you would take something like this and multiply it out. Okay? Or if you would take this type of picture, and you'd say there's 1x squared, 1, 2, 3, 4, 5, negative 6x's plus 9 of these, and then we would add the extra 4 as well. So we did stuff like that. Anyway, there is one piece of information we know about this equation, and this was from last time's homework, and that's that this last value from ax squared plus bx plus c, that the c is the y-intercept, or where the graph crosses the y-axis. So where it's going to cross this line right here. It'll cross at 9. Okay, so let's think about what we have. We have an x squared so I've drawn it down here. All right, we have negative 6x's, and again, just to make this easier, I drew them as negative squares instead of subtracting from the original length. So negative 6x's, or negative rectangles, and then we have plus 9. We have 9 little square pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the question is, wait a minute, is this area a perfect square? If we combine these like this, would it be a nice perfect square, or would we have leftover pieces? That's the question. So if we move them around, let's see, well, we could put the yellow one here. Okay, that goes there. 1, 2, 3, 4, 5, the 6 pieces. So we've used up that. 1, 2, 3, 4, 5, 6. And how many do we have for the corner? We have 9 of them. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure enough, it is a perfect square. Now we learned before the other way to figure that out is to just take half of the middle number. So half of -6, which is -3. Oh, that's what we got, a -3 here and a -3 here. And square it. -3 times -3 is 9. Sure enough, half of the middle number squared is 9. So if you can take half the middle number and square it, and you get this end number, or half of b squared is c, then it'll make a perfect square. So we're back to that picture right here. I want you to write the new equation. So take this original one, and I've recolored it. So we have our x squared, our 6 negative x's, and our plus 9. Here's our 9. Can you write that as x plus or minus something squared? Okay, can you turn this version into this version type thing? Okay, and we've done that before. Think about it. When you do, you'll be able to find the vertex of the parabola and graph it. Next, we need to talk about a different version. X squared plus 4x plus 2. Does this expression fit a perfect square? And just like we said before, the way to check is divide the middle number. So 4 divided by 2 is 2. And square it and see if it turns into the last number. Or divide b by 2 and square it and see if it turns into c. 2 squared is 4. 4 is not 2, so no, it's not a perfect square. Okay, we're missing 2 pieces for a perfect square. Here's another way to think about that. Okay, so I'm going to take this picture right here. Excuse me, I had leftovers. Okay, and I have my x squared. That's this green x squared. And I filled it in. My 4 x's, and I filled them in. So here was my x squared. My 4 x's. 1, 2, 3, 4. And I have 2 pieces right here. 1, 2. Okay, now if I draw that into a square, which I had on there before, you see to be a square, we're actually missing 2. We don't have enough. We're 2 short. So that's what I have right here is we're saying, hey, look, if you take the x squared plus the 4x and make it into a square, if you take this square, that's x plus 2 squared, that's this part right here, x plus 2 times x plus 2. But in order to get an actual square, okay, we need 4 pieces, and we only had 2, so we were short 2 to get that full square. All right, so here's how you do it algebraically, and I have it on here still, I don't know why. You take half of the middle number and square it. So half the middle number squared is 4, and what you do is you add 4 here. That fills in this square, and then we're saying, okay, we're adding 4, we need 4 for this square, so we're going to take the 2 that we had, we added 4, but we needed 4, and so we were short 2, and then we can rewrite this as x plus 2 squared. I'm going to show you another one of those, so that may have been confusing, just write it down. All right, it says, is the equation you have written equivalent to the original? So is the first one equivalent to the other one? And the answer is yes. Okay, because look, x plus 2 squared was this big square, but when we subtracted 2 to make it match this number of things in the picture. Okay, also we just algebraically manipulated it because we added 4 and we subtracted 4. 4 plus -4 is 0, so we really just added 0 to it. We didn't change it, we just moved numbers around. Now that you have this new graph, I would like you to graph it, just like we did before. And I'm actually going to go ahead and do this one for you. So you'd be at 0, 0, up 1, over 1, something like this. But remember, this moves it left 2 and down 2. So it's actually going to go 1, 2, and down 2. And that is a picture of that equation. Okay, here's another one. Jenny hoped that she wasn't going to need to figure out how to complete the square in an equation where b is an odd number. Of course, that was the next problem. Help Jenny find the vertex of the parabola for this quadratic equation. And we actually talked about this in a previous task where we said, this is task 2.3, what happens if b is an odd number? And we found out we would have fractions in our answers. So we've done this in task 2.3. Okay, but let's do it. So we're going to take our picture again and say, okay, we have an x squared. We're going to try to manually make it into a legit square. I have 7 x's, and remember, we're going to take that middle number and divide it by 2. So 1, 2, 3, 1, 2, 3. That's 6, but I need 7. So what I really need is 6.5, or sorry, 3.5 and 3.5. And that would give me a total of 7 of those rectangles, which we're calling x. And then if you were to fill in the picture, that's what our square would look like. Okay, now, so we have x squared plus 7 x's, because 1, 2, 3, 4, 5, 6, and 2 halves make 7. And now we have 10 squares. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and here's 2 halves, so 10. Oh, look, we're short some again. How many are we short? 1, 2, 3. Oops, that's 1, 2. Those 2 halves, that's 1, 2, and a quarter. We're short 2 1/4 little tiles. So let's see what that means. That means we have this big square, so that would be x plus 3.5 squared, x, and this is plus 3.5. And what we would have would this be this whole purple square, but really we only want this plus 10. So we were actually short 1, 2, 3, oops, sorry, 1, 2 1/4. So we need to take the original amount and subtract 2 1/4 to represent just the pink, the blue, and the green areas. Here's how we do it with mathematically. Half the middle number squared tells us that this whole corner right here is going to take up 12 1/4 spaces. And then we say, okay, we're going to add 12 1/4 and subtract 12 1/4. Adding 12 1/4 fills in my square, and I can rewrite it as a square, but we only had 10 green ones, and we used up 12 1/4, so we were short negative 2.25. Again, that's showing the picture. Now I'm going to do one without the picture. Here we go. Don't worry if you had a hard time thinking about number 5. Jenny has to do a couple more. And so here's the actual steps. Step number 1, look at the problem and add a space. So that's what I did. Step number 2, it says b over 2 squared. Take half of the middle number and square it. Half of negative 1, because this is an invisible 1 right here, is negative 0.5. Negative 0.5 squared is 0.25. And then it says add and subtract that to both sides, or to both things. So I'm going to add it right here, and I'm going to subtract it right here. This completes my square for me. Okay, that's what my square is going to look like. And so now it says write the square. Okay. This part right here turns into that. And then see what happens. Did we have enough square? Do we have enough stuff, or were we short stuff? And what goes in the space? These two numbers combined, we were actually short 5 1/4 pieces because we were already in the whole 5, -5, and we needed another quarter to complete my square. So let's try that again with something a little easier. Okay, I'm going to change that middle number to 6 to make it easier. And we're going to say, rewrite it with a space, move the 3 over. Number 2, take half of the middle number and square it, and then add it to both parts. So add 9 and subtract 9. Now step 3, rewrite this as a perfect square, which is always x, and half of the middle number, so that's -3 squared. And then this part, we're going to figure out what this was. 3 minus 9 is -6. These steps will always help you rewrite it from standard form, which this is, to vertex form, which this is. All right, just one more. Here we have another one. We want to turn it to vertex form, but this time it has a 2 in the front. So we talked about that before. That means we have 2 quilt squares, or 2 squares instead of 1. So the first thing we have to do is divide by 2, so that we just have 1 square. And so I've done that. Okay, x squared, -12 divided by 2 is -6. 17 divided by 2 is 8.5. Now we're going to do my steps again. Step 1, write it with spaces. Step 2, take half of the middle number and square it. That's -3 squared, which is 9. The next step is to add 9 and subtract 9 to both parts. And now lastly, we just rewrite it. This becomes x minus 3 squared. Again, it's always this half of the middle number goes right here. And 8.5 minus 9 is -0.5. But remember, how many squares did we actually have? We actually had 2 of them, so now we need to times everything by 2, which would give us 2 of those squares. And -1/2 times 2 is -1. This would be my new equation. Again, you really just need to know how to do the procedure and hope that this picture, as we talk about it, starts to make sense. So I've got this graph right here. We would have been at 1, 1, -1, 1. Here's my original one. Okay, but how does it graph? It needs to go right 2, and this -1 is down 1. So I'm going to do that. Right 2, down 1. But we're still not done because we haven't talked about what this 2 does. Remember, this 2 is going to stretch it. So instead of being over 1 and up 1, we're over 1 and up 2. 1, 2. So it's going to be skinnier. This purple parabola is actually the graph of this equation right here. All right, good luck on the homework.